Ladies and gentlemen, good day. Right now, let's talk about science, specifically chemistry, and even more specifically, solutions. Yes, I know that a solution is synonymous to solving your problems, but we're not here to talk about your sad life right now. And I'm sure that it's also a way of getting correct equations, but this ain't math. So don't get your hopes too high. Maybe we can talk about these subjects in the next few episodes, but we're probably not gonna have another episode, so don't get your hopes even higher. So the first thing you need to know about a solution is that it is a homogeneous mixture composed of one or more solutes being dissolved by a solvent. Now we know that a solution is composed of two substances called a solute and a solvent, or a solvent and a solute. Either way, it's a solution. So these two substances are defined as the solvent, in which the solvents dissolve the solutes, and solutes being dissolved by solvents. But one thing we need to keep straight is that a solvent needs to have a greater amount than a solute in order for the solvent to dissolve the solute. So solvents and solutes can occur in the three phases of matter: the solid, liquid, and gas. And there are three types of solutions. We have the dilute, in which the solute has a small amount than a solvent; a saturated, in which there is an almost equal amount of solute and solvent; and a supersaturated, in which there is a great amount of solute that in order for the solvent to dissolve the solute, the solvent needs to have a high temperature. So now let's have an example. We have water, and just the trivia, water is the universal solvent because it can dissolve almost all substances as solutes. And we have one of my favorite things in the world, coffee, as our solute. Again, water as our solvent, coffee, powdered coffee, 3-in-1 coffee as our solute. So you can see we're going to pour our solute on the solvent, in the solvent. And as I mix it, and mix it, and mix it, the solute is being dissolved by the solvent, in which the solute and the solvent joins each other. And now we have coffee to keep us awake an entire night.
Chemists can classify matter as solid, liquid, or gas. But there are other ways to classify matter as well, such as pure substances and mixtures. Pure substances have a definite and constant composition, like salt or sugar. A pure substance can either be an element or a compound, but the composition of a pure substance doesn't vary. Under pure substances lie elements and compounds. An element is composed of a single kind of atom. An atom is the smallest particle of an element that still has all the properties of the element. Here is an example. Gold is an element. If you slice and slice each chunk of gold until only one tiny particle is left that can be chopped anymore without losing the properties that make gold gold, then you've got an atom. The atoms in an element all have the same number of protons. Protons are subatomic particles, particles of an atom. Elements are the building blocks of matter, and they are represented in a strange table that you may have seen at one time or another, the periodic table. While a compound is made up of two or more elements in a specific ratio. For example, water is a compound made up of two elements, hydrogen and oxygen. These elements are combined in a very specific way, in a ratio of 2 hydrogen atoms to 1 oxygen atom, also known as H2O. Many compounds contain hydrogen and oxygen, but only one has that special 2-to-1 ratio we call water. The compound water has physical and chemical properties different from both hydrogen and oxygen. Water's properties are a unique combination of the two elements. Chemists cannot easily separate the components of a compound. They have to resort to some type of chemical reaction. On the other hand, mixtures are physical combinations of pure substances that have no definite or constant composition. The composition of a mixture varies according to who prepares the mixture. Although chemistry dudes have a difficult time separating compounds into their specific elements, the different parts of a mixture can be easily separated by physical means, such as filtration. For example, suppose you have a mixture of salt and sand, and you want to purify the sand by removing the salt. You can do this by adding water, dissolving the salt, then filtering the mixture. You then end up with pure sand. Mixtures can either be homogeneous or heterogeneous. A homogeneous mixture, sometimes called as a solution, is relatively uniform in composition. Every portion of the mixture is like every other portion. For example, if you dissolve sugar in water and mix it very well, your mixture is basically the same no matter where you sample it. However, a heterogeneous mixture is a mixture whose composition varies from position to position within the sample. For example, if you put some sugar in a jar, add some sand, then give the jar a couple of shakes, your mixture doesn't have the same composition throughout the jar, making it easy to separate. Because the sand is heavier, there's probably more sand at the bottom of the jar and some sugar at the top. So in a nutshell, the difference between pure substances and mixture is that pure substances have the same composition and properties all throughout, while mixture is the combination of two or more pure substances where each substance retains its own identity.
This is a lesson about chemical compounds. But before we tackle about it, there are possibilities that you still don't know the difference between a molecule and a compound. So before that, let me explain first what a molecule is. Basically, it is a molecule when two or more elements join together. For example, 2 hydrogen atoms is a molecule. 2 oxygen atoms is also a molecule. Water, which is an H2O, is also a molecule because it got 2 elements. On the other hand, compound is when 2 or more different elements bound together chemically, they form a new substance with its own properties. That's why any compound is a molecule, but not all molecules are compound. For example, a molecule of 2 atoms hydrogen and an atom of oxygen, which is H2O, is a compound because there are 2 different elements forming it. Calcium chloride, composed of a metal and a nonmetal, so it is an ionic compound, is also an example of a compound, except that ionic compounds are not considered to be molecules, which is a wider session for you to know. Hydrogen chloride is also a molecule and a compound, which is to say that 2 hydrogen atoms is a molecule but not a compound. So, how about compound and mixtures? Compounds are composed of different elements that were combined chemically, while a mixture is a combination of elements mixed physically. For example, salads and cooked rice with bread, or anything that you have mixed but you could still be separated because, well, they were not one in the first place. On the other hand, an example of a compound is when elements are chemically mixed. For example, when you heat the mixture of sulfur and iron fillings, the heat bound the elements together, and you won't be able now to separate the iron fillings using a magnet because the temperature changed their substances, and in fact, it has already turned into another substance. It's like when the salad is ground using a mixer, and it will bind them to the point where you won't be able to separate the vegetables and the bacon. Another is When sugar is heated, it turns to this delicious sauce and you won't be able to turn it back into the crystalline sugar rains again.